Good day and welcome to the Math Salon. I'm Dr. Anumendem. Today we'll look at some advanced level questions on integration. So the first question says we should integrate e to the cos x sine x dx from 0 to pi. So in order to do that, when you have an integral to do, it's important to look at the function that you have. Now we have two functions here. In fact, we actually do have three. There's sine here, there is an exponential, and there's a cos there. But however, there is sometimes a possible relationship that you can see. And if you can recognize one, then that is nice. For example, I see that if I differentiate the cos of x, I get a minus sine x. So I can use a substitution. Let's say, for example, let u be equal to cos x. That means my du is equal to minus sine x dx. So if that is true, then it means I would just say, okay, I can take this function here, or my integral 0 to pi dot e to the cos x sine x dx becomes the integral from 0 to pi. Notice here that if I take this minus and put on this side, then I get minus du is equal to sine x dx. So I have my e here, u is cos x, so I replace the cos x with u, and sine x dx is equal to minus du. So I just put the minus outside and I put du there. Then this is a simple integral to do. The integral of e to the u is just e to the u, because the derivative of e to the u is e to the u. So this is simply minus e to the u, and I will take 0 to pi. But you have to watch out. We introduced u, so we have to put back the original one. So u was originally cos x. So this is equal to e to the cos x, the minus outside, do not forget, from 0 to pi. And if you do that, well, this is e minus e to the cos of pi is minus 1 minus e to the lower limit, cos of 0 is 1. So if you like, you can simplify this. This is supposed to be, sorry, we forgot the minus. So this minus becomes a plus. And this e to the minus 1 is 1 over e. So you can actually simplify this. I don't have space there, but something simple. We move to the second one. We have an integral from 1 to 4 of this quotient here, x divided by x squared plus 1 dx. Once again, I try to see if there's a relationship between these two functions, that in the numerator and that in the denominator. If I differentiate here, the denominator, I get 2x, which means it's very close to x. The difference is that I don't have 2 here. So I can force a 2 there. So it means I can say 1 over 2x divided by x squared plus 1 dx. If that is true, it means if you apply a substitution technique, again, it's going to work. You can actually substitute here. Then we'll see, of course, what happens. So let's say you let your u be equal to x squared plus 1. Then your du is equal to 2x dx. So it means, once again, this will be equal to half the integral of 1 all over u, because this under now is u is x squared plus 1. But here 2x dx is 2x dx, so that becomes du. And this is a simple, the integral of 1 over u is ln u, the natural log of u. And that is, of course, I don't forget my limits. And that is half ln u. And you have to put your limits. But of course, remember, u was introduced here by us. So this is actually equal to half ln of x squared plus 1. And you put the limits 1 to 4. You can also simplify that yourself. Just plug in the upper limit, simplify minus the lower limit, and that is done. For question number 3, find the area of the final region bounded by the curve, this and the x-axis. This is our coordinate axis. If I open this function, I get 2x minus x squared. The coefficient of x squared is minus, so it's a maximum function. So let's say it's something like this, and we are going to look for this position. X equal to 0 there, so actually, if we want to sketch properly, then it will go something like that. This is just a sketch. So this is the area we are about to look for. So in order to do that, we know that on the x-axis as here, y values are 0. See, this is y1, y2, y3. So on this line, x is equal to 0. Sorry, y is equal to 0. That means 0 is equal to x multiplied by 2 minus x here. That means there are two solutions here. X is equal to 0 or x is equal to 2. Just obtained by solving this. If this 2 multiplied to give 0, it means either this is 0 or this is 0. But 2 minus x equals 0 means x is equal to 2. So actually we are going to look for the integral from 0 to 2 of that function. And this is normally a simple one. If you open this out, this is the integral of 2x minus x squared from 0 to 2 dx. And this is actually equal to integrate, you increase the power and divide by a new power. So this is 2x to the power 2 divided by 2 minus, this one goes up to 3, x to the power 3 divided by 3 from 0 to 2. You can simplify as well, just like above. Then we can gain some time in looking at more questions. And for the last one here, we are to evaluate this here, indefinite integral x squared divided by x plus 1. So this is x squared. So here what you notice is that I have a function on the numerator and a function in the denominator. But the function, the power, the degree of the numerator is bigger than that in the denominator. So the first thing we try to do is to do a long division here. And yeah, there are several ways of doing that. One of the easiest one is this. X squared is there. This is x plus 1. X squared divided by x is x. X times x is x squared. X times 1 is x. You subtract. X squared minus x squared disappears. Then this becomes minus x here. Minus x divided by x is minus 1. Minus 1 times that is minus x. Minus 1 times 1 is minus 1. If you subtract, these two fall off and I get plus 1.